Hello friends, my name is Shivam from DevOps Schools and I will help you to enable your learning process in various technologies of DevOps, artificial intelligence, machine learning, big data and many more. This is our initiative to help you by sharing multiple tutorials and videos. And if you want any specific tutorials on any particular topic, then please do comment in the below comment section and I will help you with it. Also, please subscribe to our premium services on YouTube, which will give you access to more content and videos to enhance your knowledge about all these topics. Also, if you want me to help you with regards to the online trainings and classroom sessions by our qualified trainers, then please do write me at contact@devopsschool.com. Thank you.
Any doubt in this chapter? Either you can unmute yourself. Okay, I think everything is clear to all of you. Okay. Now this is very interesting chapter which we are going to see, which is a TCP/IP addressing. Okay, this is nothing but a chapter number. Oh, this is a chapter number 5. Correct. Now this is a very important chapter because that will give you the idea about IP addressing. Okay, this will give you the idea about how IPv4 is working. Okay, now we are focusing about IPv4 today, and we will talk about IPv6 later on. Once we understand every IPv4 activities, then we should go for IPv6, otherwise you will get confused. Okay, so first of all, understand the complete IPv4, how we can do that. Correct, this is very, very important to understand. Correct. Now after that, default IP addressing swing. Now here you will be understanding basic of IP addressing. Tomorrow we will go deep dive into IP addressing. We will talk about the concept called as subnetting. Okay, the concept is called as dividing the IP addresses into the smaller chunks. We will call it as subnet. Correct, that we will see tomorrow, but before you should prepare with IP addressing, because subnetting is very, very important topic when you are going for CCNA exam. Okay, they will ask you to create subnetting. You need to understand how subnetting work. It is a complete calculation. You need to calculate it. Correct. So, but before that, if you understand this chapter, it is very good. After that, TCP/IP suite, custom IP addressing scheme, that's fine, no doubt about that. Okay, now look at connection oriented protocol and connection less protocol. Yesterday we discussed about this. Okay, what is a connection oriented protocol and connection less protocol? Connection oriented protocol is nothing but our TCP. Now connection oriented means what exactly he do. Correct. Connection oriented means he will make sure that the connection should be established first with three-way handshake, and after that only he would be able to send you the data packets which is expected. Correct. So this is a difference which we can use it, or which we can see it. Okay, now you can see three phases, that means a three-way handshake which we are going to talk about. Correct. So connection oriented protocol, make sure that before you send the data, the connection should be established, data transfer should be happen, acknowledgement should be done for every data packets, and once it is done, he should close the connection. correct? It can work in such a way that TCP will send the data in a sequential fashion. Okay, you can see connections are established before data is sent. That means what I told you, TCP, what he will do, he will send hello, correct? Then the other machine should once again send me hello, correct? Once the hello hello has been done, the connection would be established, correct? Now, if the connection is established now it is ready to send your data in a sequential fashion. I told you in a transport layer, the data would be segmented, and every segment of the data do have a unique sequence number, correct? That sequence number would be managed and maintained by transport layer. With the same sequence, the data would be transferred. If any of the sequence would be missed, my machine would start sending that sequence one more time to the destination. This is talking about, correct? But in connectionless protocol, there is no connection like that. Data can be sent with very different manner, very different paths would be there, correct? Now he will always start transferring. He will not going for any kind of a handshake. He cannot be able to guarantee whether the data has been reached to the destination or not. He do not do anything, correct? Now can function only bi-directional communication environment. Now that it has to be bi-directional, otherwise you won't be able to get the acknowledgement, correct? Now, okay, now here information is sent to the destination whether he is ready or not, correct? Now this is something interesting in the case of connectionless protocol. Connectionless protocol never asks for any kind of a connection, never asks for any kind of acknowledgement. He will directly give you the data, correct? Now this time it is sometime what happened, whether my server is not ready to accept the data, but I am giving you the possibility is that sometime I am not ready, but you are sending me, I'm not able to process it, correct? So sometime my particular data which I am receiving from someone else and someone other who is trying to send me the data again and again to my particular computer, and I'm not accepting it, correct? In that particular cases, my particular UDP or any connectionless protocol need to retransmit the data again, not just for whether it is not reached, but my computer is not ready to process it. The processing is not happened, correct? So that's why connection oriented protocol is very safe as compared to connectionless protocol. Then also people ask me whether we are using connectionless protocol. Yes, we are using it in a cluster environment. Okay, in a cluster environment where I don't require any kind of a three-way handshake to be happen. I just want to send some notification data to my server. Correct? That's it. If I would like to have any kind of such implementation where I need the data to be transmitted in a faster way, okay, I don't need to bother about it whether he is processing it or not. I just send it. In that situations, I would be able to use connectionless protocol, correct? Which is very faster protocol which we can talk about, correct? Now let's get to the next slide. Now where the transport layer is under fourth layer from the bottom, there are two different protocol which we have already discussed. Now we already discussed what is a TCP. It is a transmission control protocol, connection oriented, correct? This is a very important thing. Guaranteed delivery protocol used to send the data packets means I will make sure that your data should be reached to your destination, correct? TCP is a part of TCP IP protocol suite. Now this is what they are talking about. I will show you. If I go here, go to the open network connections. Okay, I'm using Wi-Fi. Okay, now if I go to this, if I go to properties, okay, now this is TCP IP stack. Okay, now this is a stack by default in my operating system. Whatever data transmission would be happen, my entire data transmission would be happen by default TCP IP stack. TCP is a transmission control protocol which can transfer your data over IP. So this is the part of the TCP IP stack by default. Correct? End-to-end, ensure end-to-end delivery. That means every data packet which is received on other side, my particular TCP will ensure that I should get the acknowledgement whether the data has been received or not. Correct? My TCP will always make sure that before I transmitting actual data, the connection has to be established before the actual data transmission. Correct? Now, at the source node, break the data into the segment and send it and wait it for acknowledgement. This is what I told you. The segmentation is the important. Chopping the data into the smaller chunk based on the MTU size. Provide the sequence number. Keep sending all the sequences. On the other hand, make sure that every sequence he should have the acknowledgement. If every data has been transferred to other end, he will also make sure that entire things are done. He will rebuild that particular data and it would be finalized and the connection would be broken now. Correct? You can see reassemble the segment into the original data because he chopped the data. He need to reassemble it once again once all the data packet is received on other end. Otherwise, it would be in a chopping statement. So transport layer will also make sure that once the data has been dropped, on other hand, he should reassemble that all the sequences which he chopped as a original data, and after that he will broke the connection. Correct? If any data has been lost, he can resend the data back. No problem. Now, on other hand, it is UDP. What is that? It's connectionless. Okay, he will not ensure anything under that. Now IP is using, okay, it used IP. Now there are some connections which is running on your machine which works as an UDP. I will show you what kind of UDP examples are using. Now you can see for VoIP real-time network management applications, these are the areas where you can use this type of connection. Now, voice is the best example for UDP. If I'm talking with you, I'm not getting any acknowledgement whether you are listening or not. Correct? I can only able to get whether you are listening or not when you type into the chat message. But your computers won't be able to send me any reply back for my voice messages. You are able to listen. That is the only thing. Correct? So this is VoIP is the best example for UDP. Videos. Correct? Whether you are getting the video or not, it does not bother. Video streaming applications are actually UDPs. Correct? Even our video conferencing which we are doing, that is also the best example of UDP. Correct? So UDP is a transport layer protocol. It's connectionless. It would be very fast because he's not waiting for any acknowledgement. He will not wait for any connection to be established. He will start sending the data directly. correct? It is definitely very faster than TCP. In a very cluster environment, we are using this type of protocol a lot. Correct?
Hey viewers, our Master in DevOps engineering program can help you to hone the skills necessary to succeed in high-level DevOps positions. So, what are you waiting for? Enroll now and earn certification that show you are keeping pace with today's technical roles and requirements. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
Now this is internet protocol. Now this is network 3 protocol. Correct? Now this IP protocol would be responsible for to create a packet. I told you in a network layer 3 it is a packet. Correct? He will understand. This is a protocol who understand IP addressing. He understand how to read the routing table, how to find out the best path. Correct? And provide that all the information to TCP. Okay, TCP, this is the best path, you can go for it. To find out the best routes, to put all those routes into the routing table. Correct? Now IP will actually help TCP and UDP payload to find out the best option to help you. Correct? This is a very important. We know that IP means IP address. Okay, but that IP is nothing but a protocol stack, and you are providing some unique logical number to that to identify. But that protocol stack actually help us to understand that numbering system, to understand the best route to find out, to understand the best routing which we can use it. Otherwise, your machine won't understand any this decimal numbers at all. They will only understand binary. But how these numbers can be understandable for my computer? Because of IP protocol. TCP IP stack means what? TCP stack used for transporting, IP stack for understanding this numbering system and helping the TCP stack to make that particular data transportation proper. Correct? He is very important protocol stack which will help us. So remember that whatever communication which is currently happening, by default we are using TCP IP stack. Correct? Both the protocol suites are there. One protocol help us to create a connection, transport the data, acknowledgement, and other protocol help us to find out the best path, to find out the best route, help the transport protocol to make the delivery faster. Every supported activity would be done by IP protocol. Correct? So this is the IP protocol thing. Now ICMP. Now everybody knows about this. What is a ICMP? This is the Internet Control Message Protocol. Correct? We are using it for a command called as ping. Okay? We are using it for traceroute utility, behind the scene ICMP protocol, which we can use. This protocol is actually working in layer 3. Remember that many times such questions people will ask you in your exam. Ping command works on which layer? Now ping is a command, but behind the scene there is a protocol called as ICMP. Correct? That ICMP protocol actually work on layer 3 model. Correct? Now what would be happen in ICMP? We will see in the details, but let's say whenever I try to ping any command to find out whether that specific destination is alive, whether it lost or what happened. Correct? The reason behind it, what we are actually doing, we are creating a data packet over IP and TCP is my carrier. I'm using this protocol called as ICMP to take this particular ICMP data with hello message into that. So there has to be some payload. Now ICMP packet is actually work on IP addresses. It work on logical number. He will take that particular packet and he will try to reach to that particular destination with hello packet. Now once that hello packet is dropped over there, and he will say, okay, I should say, he will also send me some packet back, correct, as a response of that particular hello packet. ICMP help us to display that he is giving me reply, correct. Remember that ICMP is a protocol who can take this particular packet over IP and make sure the response should be coming back from that particular server. When that response is coming back from that server, he will show me the message on my screen that okay, replies are coming from that particular protocol, and we are able to see that yes, that particular machine is turned on, that particular machine is actually processing my data, correct. So this is ICMP protocol. Currently, whatever basic activity which we are doing, like a ping command, trace route activity, behind the scene, ICMP protocol is trying to send hello packet to that particular destination, and with the response, whatever response they are getting, they are putting that response on the screen. Sometimes we are getting the message called as request timeout. The reason I sent the packet, I couldn't get the response, correct. So that packet would be dropped. I'm not getting any response. So there is a pre-done configured things are there. It would say this is not available. Echo reply, that means that particular computer is sending the message back. He's giving me echo for the same message. So that's the reason that message would be displayed on my screen. So remember that we will go deeper dive when we are practically doing ping and trace route command. That time I will explain you what exactly happening behind the scene and how we can use this command with a multiple ways in order to understand it. Correct? Sending host, receiving host, destination unreachable. Okay, this is something. Now ARP, I told you about it, but remember that ICMP is your main point is what? ICMP is working on layer 3. This is very, very important, correct? After that ARP, now this is called as address resolution protocol. I told you what is the purpose of this particular protocol is to make sure the table should be maintained. This is a table on your every device, whatever layer 2 devices which you guys are using, all that particular devices work with ARP. So address resolution protocol that will help us to maintain the IP is equal to MAC address within layer 2. That means within local area connection would be working on MAC addresses. So ARP protocol always help me to find out the destination MAC addresses. Correct? This is very, very important protocol in order to do the communication within local area connection. Otherwise, it would be very difficult because you can imagine I cannot send the data with the help of MAC address. I always prefer to send a data which I can memorize or which I can manage properly. That is nothing but IP addresses, correct? So I should have some mechanism running on my system who can tell me while generating that particular data, I need to provide the destination MAC address to check whether that destination is available locally or not, correct? So ARP helped me to do that. ARP just helped me to find out, okay, this is the IP address is equal to MAC address, finished, correct? It is also encapsulated by Ethernet here. Obviously, I should provide the destination MAC address, destination IP address, source IP address, source MAC address, everything should be loaded over there. So obviously it is the part of my header, correct? So don't worry about that information about ARP. So this is called as ARP protocol. Port mirroring. Now this is something which we used to have long time back. We know that we working on the concept called as logical port, correct? Logical port, we know about that there are 0 to 65,536 ports are available. Every port do have a unique facility. A service is running on that particular port. I will give you the example, then you will get an idea what is the port mapping thing. Technically speaking, we are not using this technique anymore because we do have a better techniques available. Let's say if I have any web server or any server which I'm running, let's say I would like to run web server over here. For example, I do have a Tomcat over here running, and there is a client machine. Okay, now this is Linux server. This is also Linux server, for example. Okay, now this particular website which I would like to deploy it is running on a Tomcat. Now if I would like to run any service which is a web service, I know that there is a logical port number 80 and port number 443 if it is a secure one. Port number 80 and 443 should be enabled. Now why it is like that? Because some organization which is called as INA, INA organization actually predefined that protocol called as HTTP should work on port number 80 and port number 44. That is a logical endpoint, correct? If I close this logical endpoint on the firewall, this client machine won't be able to communicate with my website, correct? This is interesting. That means the logical port is associated with a service. If that service is running on my machine, ultimately those endpoint associated with that service is running. People say, can I change this port? Yes, because service is associated with that. You can go to the configuration of the service and you can change that, no problem. There are 65,000 ports are available. You can use any particular port after 1024. Any customized port you want to use it, you can use it. It's not a big deal, correct? The only concept you need to understand that these are logical. This is not physical. I install the Tomcat. Ultimately, Tomcat know I am sending the data over HTTP protocol. I will work on a port number 80. That's it. This is predefined. Then what is a port mirroring will do? Look at here very carefully. Okay, very carefully. Practice of duplicating all the traffic from one port in the switch to second. Now I know that if I do the local port mirroring, correct, I will do the mirroring of the port and I will make sure that whatever traffic which is coming to me, the same traffic would be replicated to other side, correct? It is simple a technique where I will mirror the port on a device and I will make sure that whatever traffic which is coming on that particular service, the same traffic would be replicated on other service as well, correct? This is very important technique which we were using long time back when we don't have any kind of a load balancing facility. Our switches was not so much intelligent, but nowadays we are not using this technique anymore. We are using the concept called as NIC bonding. That is the most appropriate method to do this, correct? Don't worry about the port mirroring. We cannot be able to do the practicals of it because we don't have any option, because this is an activity which we need to do it. Correct? Now the next is, this is something we are going to understand. This is very important chapter that is called as IP address. Now, if you look at your computer and if you go any IP address, now for example, I'm checking this IP address.
Hey viewers, trying to get into DevSecOps? Enroll for our DevSecOps certified professional programs and earn the certification that shows you are fit for these technical roles and requirements. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
Now, if I see it, but I have not copied it. So this is the IP address which I'm getting. Correct? Now, if you look at this IP address, it is divided into 4 different parts. Right? 1, 2, 3, 4. Okay. So you have to make sure that this number, every number is a decimal number. You can see this number is a decimal number. It is what? It is a decimal number. Now, why it is a decimal number? Because it is easy for me to manage it. Correct? So it is easy for manage it. Now, this entire number is a 32-bit logical address. Okay? That means every number which I am getting, it's a 8-bit number. Total is 32-bit. So every section, okay, every section would be a 8-bit over here. Correct? So total I do have 4 numbers. So 8 into 4 is equal to 32 bit. So every number is a 8-bit number, which is written in a decimal format. Correct? So if I say 192 dot 168 dot 1 dot 4. So this is, I'm telling, this is the number which I am talking about. Now every number is what? 8-bit number. Correct? Now this is a decimal number. To be honest with you, my particular computer don't understand the decimal number at all. My computer only understand the number called as binary. What my computer can understand? The number called as binary numbers. This is something which we can say 1 and 0. So I do have only 2 numbers available. Correct? So the first procedure we need to understand how to convert any decimal number into binary. Correct? To be honest, if you go to the Google, there are many calculators are available who can do that. But we need to understand how this particular decimal number, we can convert it into the binary number with respect to IP addresses. Now I know that the IP address would be 32-bit long. Correct? So if I say this IP addresses, if I would like to use it, okay, I would say write it down in this format. Okay. Okay, I will say 0. Okay, it has to be start from here. Okay, I will say 0. Okay, I will say 2. I will say 4. This is 2 raised to 0, 2 raised to 1. Should be something. I will write it down. Don't worry about that. It's 16, 32, 64, 100. Correct? So this is something which I'm talking about regarding 8-bit. So this is nothing but 2 raised to 1. So 2 raised to 0, 2 raised to 2 raised to 2, 2 raised to 3, 2 raised to 4, correct? 2 raised to 5, 2 raised to 6, and 2 raised to 7. This is my 8-bit, which is starting with 0, end with 7. So this is the 8-bit which I'm talking about in a binary fashion, correct? So this is a 8-bit which we are talking about. I told you that every single character is it of 8-bit. So this 8-bit actually, if I want to write it in a binary syntax, this is how it would be. So what is the maximum number I'm getting over here? If I add 250, 128 plus 64 plus 32 was 16 plus 8 plus 4, what would be the number I would be getting over here? 256. So this particular first column, I would say the maximum number would be reaching over here would be 256, correct? But in a writing fashion, I'm not writing 256 because it always start with 0. So it will start with 0 and end with 255. So every single bit, this one, okay, and this one, what is the starting point? Starting point would be 0. What would be the end point? The maximum end point would be 255 for every section of the number, correct? So understand, this is very, very important to understand the IP addressing, because right now we have a calculator available, but still understand how this particular concept has been designed and developed, correct? So you can see, as per the theoretical model, this is a 32-bit logical address written in a decimal format. But I told you, computer does not understand any concept in a decimal format at all, correct? He only understand the concept in your particular binary fashion. So if I would like to convert this 8-bit in a binary fashion, it should be written in this format, correct? This is my complete 8-bit. Yes, this is 8-bit. So what is the maximum and minimum number I can write into this particular section? Total number would be 256, no problem. But if I write it down, it will start with 0 to 255, total would be 256. So the minimum number would start with 0 for every section, and the maximum number it will go would be 255, correct? So remember that this is very important. Now if I say I would like to say 192, how do I convert 192 in a binary? It's very simple. If I would like to convert this number into the binary format, I'm using this formula. Now this is the same 8-bit for every section, correct? I would say 192. Now how do I adjust 192 over here? Now maximum number would be 255, correct? No doubt about it. Now what would be the 192 do? Now if I say, if I take 128, 1, 64 means 128 plus 64. I should get 192, and rest of the number I will say it is 0. Okay, so 192 would be, the binary number would be something like this, 110000. And how we can find out? 128 plus 64, the binary number would be 11. Rest of the things are 0. Whatever decimal number conversion which we required needs to be done in a binary. 192 is equal to this binary number. Correct? This is interesting. Now, what about the other numbers? Okay, we will do that. Now, understand how I am doing. This is, once again, this is 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 5, 2 raised to 6, and 2 raised to 7. Okay, I'll start with 0. Correct? Now let's talk about 168. Now, can I take this 128 in the picture? Yes, I can take it because it is less than 136. Can I take 64? No, I cannot take 64 because 128 plus 64 already I know 192, and 168 is less than 192. So I cannot take it. So I would say 0. Can I take 32? 128 plus 32 would be 160. I believe, yes, I can take that. Okay, so I got 160 over here. Can I take 16? So if I say 128 plus 32, already done 160. If I take 116, it's 176. Oh, I cannot take it. Can I take 8? Yes, I can take it because 128 plus 32 plus 8 would be 160. Correct? So I'm getting that particular value. Rest of the thing would be 0, 0, 0. This is 1 actually, it's not 0, it's 1. Correct? 2 raised to 0, it's actually 1. Okay, so remember that I missed it. Correct? So this is something which we can get. So this is called as decimal to binary conversion. Remember that. Correct? So you have to write something like this into the table, 2 raised to 0, 2 raised to 1. And if I go and show you a simple conversion, decimal to binary conversion. Okay, there are many tables that are available. Okay, that will help you to understand. If I say 192 convert, it's the same thing. 168, we have just done it. Correct? If I say convert, it is the same thing. 111000. Correct? So it is the same thing which is happening. So how your computer can understand this number? Actually, your computer don't understand the decimal number at all. He would always convert this number into your particular binary format. And binary format is nothing but 2 raised to 0. This is 1 actually, not a 0. This number would be 1. Type 0. This is 1. Okay. Okay, if I would do one thing. Okay, I will do the calculation one more time with the calculator. Okay, this calculator also help us to do that. Wait, it's coming. Okay, so if I would like to go for scientific calculator or You can see if I say 168, you would be able to see this. This is the binary syntax for it, correct? If I would like to say 1, it's 001. That means this entire 0 fact, because he's going to only talk about last 4 numbers. So 001, correct? So this is what exactly computer is doing. He is actually converting your binary numbers into decimal format. If I say,
Hey viewers, are you looking for formal training on SRE practices? Take our SRE program. This course will teach you how to successfully implement site reliability engineering in the modern day 24/7 services. Kickstart your SRE training today. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
I will go to, okay, we will convert this number 128, okay, plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 to 255. So the last number would be 255. And what is missing? 16 plus 4 plus 2 plus 1. Yeah. Okay. So last number would be 255. And this is the binary digit for that. So maximum, either I should go for this, correct? Okay, this is the maximum number 11111111. 8 times 1, 1, 1, 2, 3, 4, 5, 6, 7. Okay, so either I will go with the 111 and either I will go with the 000. Correct. So this is actually the maximum binary conversion my computer can do. Everything would be happen in between that. Correct. So remember that whenever you're typing any IP address to your device, whatever device you're talking about, it could be a router, it could be a computer, it could be any device. That device does not understand any IP address which you are putting in a decimal form. He would convert it into his logic, and he will make sure that he should be able to convert that number properly in a binary format, and then only your computer would be able to understand how that particular binary format works. Correct? Is it clear? Any doubt in this? Could you please check the IP address of your computer and try to convert it into the binary format? And put it on a chat. Okay, whatever IP address which you have on your computer, find out the IP address and tell me what is the binary conversion of this particular IP address in this particular format. Okay, so understand, this is the first step to understand your IP addresses. Correct? It will start with 0. I told you, writing fashion would be starting with 0. number would be 255. Total 256 numbers would be available. Correct. 0 we will not be able to put it somewhere, but 0 do have a reference. So this is how we are going to understand this number. Technically speaking, it's very simple. Correct. If I look at into the decimal format, it is a very simple mechanism, but it is a 8-bit. Sometimes it is also called as octet. Every bit is a 8-bit. It is called as octet number. Okay, this is 8-bit. This is 8-bit. Correct. And this 8-bit, every 8-bit do have 0 to 55. So minimum number would be 0 for every octet. The maximum number would be 255. Total 256 numbers would be there, starting with 0. Correct. So type your IP address, convert it into the decimal to binary conversion that your computer can understand. Correct. Now this is what he is actually talking in this particular chapter. Okay, number range from 0 to 55, and these numbers are separated by dots. Correct. So every number which we have a dot on the die. Correct. Now IP address do have three important things. Correct. If you look at your IP addresses, you do have a IP address, you have a subnet mask. You will come to know what is a subnet mask is. Correct. And the default gateway. These are the three most important information which you required. Correct. Now IP address is nothing but it is this type of number. Correct. Now before we go into subnet mask, before that I would tell you some interesting concept before we go here. Correct. Now some people ask me whether our IP addresses which we are using, are they free or am I need to pay for it? Correct. Now the answer is very simple. Whatever IP address which you are using, correct, currently on your computer, that IP address 99% it will start with the number called as 192. Correct. If your starting number is 192, correct, second number is 168, correct, then it is free for you. Okay, it is completely free for you. You do not require to pay for that. Now there is a reason behind it. We will go deep dive into this and you will understand the complete IP addressing. This is very important chapter. First, understand this is a decimal number separated by a dot. The decimal number, it is only for our convenient to understand and manage this number. Correct. But for computer it is something very different. I told you that every bit which we are talking about, okay, every bit of that particular IP address, correct, it is a 8-bit number. Correct. That particular number would be starting with 0 and end number would be considered as your 255. Total 256 numbers would be there. Correct. Now understand very important concept. These all numbers which we are getting, whatever number, whether you are using it free or whether you are using it paid, I will tell you when to use the paid and you are using it right now, the paid IP addresses, there is an organization called as ICANN. Okay, this is the Internet Corporation for Assigned Names and Numbers. This is the organization actually handling all your IP addresses, whatever. This is the organization. This is a non-profit organization who is managing this entire series of the IP addressing. Now how? Now what they have done, they have put this IP addressing into different classes. Okay, I will erase this or I will write on this. Okay, there are different classes of IP addresses. Okay, different classes means ICANN, what they have done, they defined some classes based on their numbers. If you look at the first octet or the first number of your IP address, you will come to know which class of this IP address belongs to. Correct? There are 5 major classes. Okay. The first class is called as class A. Okay. If my first number actually start with 0 and 127, I'm talking about the first octet. Remember that. I'm talking about the first number of that particular octet. I'm talking about this one. If my first number starting with 0 to 127, then this IP address, it belongs to class A. Correct? But technically speaking, 0 we cannot use it. Correct? We cannot use the number called as 0 at all. 127 cannot use it because it is already assigned, because it is my loop back adapter IP address. So it has been already assigned. So I cannot reassign it to the computer. So the official range for class A would be starting with 1 to 126. So I will look into first number and I will find out if any number starting in this range, I would say this is belong to class A. Correct? Now this is a classification done by the company called as ICANN. This is the organization who decided that. Correct? Now this is a US based company who actually handling the entire internet. So this is what whatever numbers and names, whatever domain names which we are purchasing, the website names, that is also controlled by this. Whatever IP addressing which is handling, that is also controlled by ICANN. Correct? So this particular organization said, ICANN said, okay, any number, the first octet, it should be in between this 0 to 127. Okay, 0 I cannot use it. 127 is already reserved for your loopback address. Then official link would be 1 to 126 would be considered as a class A IP addresses. Correct? Now there is one more class they are given to you, that is called as class B. Okay, class B. The range would be given as 128 to 190. So any IP address, the first IP address comes under this range. We know that what is the maximum number I can set? 0 to 255 for first octet. Out of that 0 to 127, they have assigned it for class A. After that 128 to 191, that is assigned for class B. So any number within this range would be considered as what? Class B IP address. Correct? Then there is an IP address for class C. So any number which is starting with 192 to 223, it will become class C IP address. Correct? It will become class C IP address. Now you can see my IP address is actually starting with what? 192. So what class of the IP address which I'm using on my computer right now? It is a class C IP address. Correct? The class C IP address which I'm using on my computer. Correct? Now what is the next class? Then there is a class D. Class D will obviously start with 224 to 239. Correct? After that, there is another class called as class E.
Thanks for watching. Want to study further? Join our training programs today.